is Mr. Boggs, and today I want to talk about energy, work, and power. So let's think about some things that contain energy. We might say that objects in motion contain energy. We might say that an object due to its position contains energy. Some other things might be electricity contains energy. Compounds contain energy, and it's stored in the bonds between the different elements. And when we break down those compounds, we break those bonds and release that energy. Light contains energy. We might also say that sound contains energy. So what exactly is energy then? Well, energy is just the ability to do work. And so what is work in that case? And that might be one of those definitions that we have to look a little bit deeper at to really define what work is. And it's a little bit different than the common use of work, like I'm going to work. In science, we define work as applying a force over a distance. So anything that has the ability to apply a force over a distance is said to contain energy. And so energy is measured in joules. And so work is also measured in joules. So an example or a scenario where we might be doing work, and I'll give that example here, might be if you are at the bottom of a staircase and you're jamming out to your iPod here, and your friend comes up and he says, "Hey, what are you listening to? Let me hear that." So you run up the stairs to get him his iPod. So how much work would it actually take to get that iPod to the top of the stairs? And it doesn't matter how you get to the top of the stairs. You could go that distance, you could climb up a ladder, you could just take the stairs, or you could throw the iPod up there. But you're going the same distance, so you'd still be doing the same amount of work. So if we said, let's see, the stairs we said are 5 meters in height, and your iPod here, it has a weight of 3 newtons. And since gravity is always pulling it in a downward direction, it really doesn't matter how you get it up there. So work is equal to force times distance. So if our force is 3 meters, or 3 newtons, times our distance of 5 meters, then we're doing about 15 joules of work. And so there's another thing that we might look at, and that's how fast or how long it takes us to do that amount of work. So if we're doing 15 joules here, and if we're measuring how fast or how long it takes to do work, then we are using a different term to figure that out, and that would be power. And so power is how long it takes you to do that work. So it's our formula here would be power equals work divided by the time it takes to do that work. And so if we had our 15 joules, and let's say that it took 1 second to get up those steps. So you sprinted up the steps and it only took you a second. So you have 15 joules of work, and we did that in 1 second. So how much power would we be using? So it would come up to about 15 watts of power. So watt, the unit for power is the watt, but let's say that it took you longer than that. Let's say that you just walked up the steps and it took you 10 seconds here. So if it took 10 seconds, then we would go from 15 watts only to about 1.5 watts. So that's not a lot of power. One of the things that we use to describe power, another unit, would be that we might be a little bit more familiar with is the horsepower. So 1 horsepower is equal to about 746 watts. And so if we wanted to convert our 15 watts of power into horsepower, we could do that. And so it'd only be about a 0.02 horsepower machine. And so that wouldn't be a very powerful machine. But one thing to keep in mind, you're not only taking the iPod up the steps, you're also taking your entire body up the steps. So maybe we're a little bit more powerful than you might think.